Alrighty. With 2025 AB4, this is calculator inactive, so our side splitting no more. Very sad. Anyways, we have two semicircles and a line. G of x is from 6x of f of t dt. And the first thing that we want is to find out what g prime of 8 is. So this is another FTC part 2 where we just got to take the derivative of this. So g prime of x just becomes f of x right there. The derivative of x is just 1. You don't have to write that. Give a reason for your answer. You could just say the fundamental theorem of calculus and call it a day. By fundamental theorem of calculus. Don't say part 1 or part 2 just because it's interchangeable. So just say fundamental theorem of calculus and they'll be okay with it. So then g prime of 8 is just going to be f of 8, and f of 8 is just 1. And that's it. All right, so for part B, it says find all values of x in which the graph of g has an inflection point. Give a reason for your answer. Now, remember, g has an inflection point when the second derivative is 0 and it changes signs. The problem is, remember that you want to justify based off of the graph. Okay, in this case, you're given the graph of f, which means you have to justify this by whatever g prime is. So remember that g has a point of inflection when g prime changes from decreasing to increasing or vice versa. So in this case, that's going to be at -3, that's going to be at +3, and that's also going to be at 6 right here. So then you're going to tell me that g has a point of inflection at x is equal to -3, x is equal to 3, x is equal to 6, because g prime of x is equal to f of x changes from decreasing to increasing or vice versa. Make sure that you say or vice versa, just so that you have both. Or if you want to justify each, we're at -3, we are decreasing and then increasing, increasing then decreasing, decreasing then increasing, that's also fine. For part C, we want to find g of 12 and g of 0, and we want to label our answers. Notice how we are starting at 6 as my lower bound. So to find g of 12, that's very easy for us, because that's going to be the integral from 6 to 12 of f of t dt. And that right there is just a triangle with a length of 6 and a height of 3, which gives us 9. Now, g of 0, on the other hand, we are going to have to switch our bounds because our lower bound here is greater than 0. So we want to switch it so that we have this right here. And we want to find the integral from 0 to 6 of f of t dt. This is a semicircle. So this is going to be -1/2 pi. Your radius is 3 square. If you want to leave it like that, you can. It's an FRQ. We'll take it. And then part D says find the value of x at which g attains an absolute minimum on the closed interval -6 to 12. Justify your answer. So just like problem number 1, we need to take a derivative. In this case, we already know that the derivative of g is g prime of x, which is the same thing as f of x. And when is f of x equal to 0? Well, that's going to be at 0, and that's going to be at 6. So, we have... yeah, 0. Oh, and negative 6. We have... so, negative 6, 0, and 6. We have 4 things to check. That's not G, that's X. We have 4 things to check. We have negative 6, we have 0, we have 6, and we have 12. All right, we already know what 0 is from part C, and we already know what 12 is from part C. So they kind of gave us some hints about those two. Now going from 6 to negative 6, you'll notice that this is a semicircle and this is a semicircle. They're going to cancel out. So negative 6 is going to be 0. And then the integral from 6 to 6 is also 0. So that just cancels out. And once again, you want to read your problem. It's not asking you to find the absolute minimum. It's asking you to find the value of x. So then you would just say, therefore, the value of x at which, I'm just copying whatever the statement is. The question is, G attains an absolute minimum is x is equal to 0, and call it a day. So basically you're just restating whatever the question's asking you. All right, in the next video, we will do another calculator inactive problem where once again, we have FTC.